Good evening, everyone. Myself, Gautam Sharma. I welcome you all in a Sapience Education. So today I am going to discuss about the NCERT solution for the wave. It is totally based on the latest syllabus. Okay, I hope you have understood this. So let us try first question. The first question is that a string of a mass 2.50 kg is under the tension of a 300 Newton. Length of the string is 20 meter. If the transverse jerk is stuck at one end of the string, how long does the disturbance take to reach the other end? So let us make the figure here. Here there is a string, okay, and it is attached at the another end, okay, and it has how much length? It has length of about 20 meter. If jerk will given, so this will reach at the some time. So we need to find the time. Okay. So first of all, we have to find the time. Before that, what they have given. They have given mass m as 2.50 kg. They have also given tension. So tension will be equal to 200 Newton. And they have given length of the string as 20 meter. Okay. So we need to find the time required to move this wave. So see here, this wave will move. So how much time it required to move this wave from this position to this position? So the distance is 20 meter. Velocity, if we will find the velocity of the wave, so v is the velocity of the wave. If we will able to find velocity of wave, so definitely we will able to find time, because time is equal to velocity. Time is equal to length by velocity. Okay. So velocity of the wave, we know that the formula velocity of the wave is equal to 2 by mu, where mu is the density, mass density. So mu is equal to mass density, that is mass by length. That is equal to 2.50 by 20 meter. So if we put this value of mu as well as tension, so how much we will get? So tension is 200 divided by mu is 2.50 into 20. So when we calculate this, so our velocity will become 40 meter per second. Okay. Now we have got the velocity. So definitely if I want to find the time, so length is given as a 20 meter and velocity is 40 meter per second. Okay. So if we calculate this, so we will get time as a 0.5 second. So we will get the time as 0. We will get time as 0.5 second. Okay. So our required answer for this question is this. I hope you have understood this, right? Now we will go for a question number 14.2. In 14.2, question is, a stone is dropped from the top of the tower of a height 300 meter and splashes into the water of a pond near the base of the tower. When the splash is heard at the top of the given that the speed is, when is the splash heard at the top given that speed of the sound in air is 340 meter per second? See, let us consider this is the tower. Okay, there is a tower. This is a tower, and from this tower, a man throws a stone. So this stone will come, and there is a pond or lake near it. So what will happen? It will splash this. We need to find the time required, time of time when it heard splash. Heard splash. Okay. So let us see the time travel. See, when a stone goes from top to bottom, so the time required is t1, and when it is splash, so splash will take a time to reach this as a t2. So how you will find time t1? So we know that s is equal to ut plus half at square. From this we will get time t1. So s is the distance. So distance of the tower is how much? 300 meter. So this is 300 meter, and initial velocity is 0. So 0 into time t plus 1 by 2 into g. The value of g is 9.8, and into time t square. So from here, time t square is equal to 300 into 2 divided by 9.8. So when we calculate, so time t1, so this is time t1, this is time t1. So when we calculate the time t1, so we will get the value time t1 as root under 600 by 9.8. Okay, 600 by 9.8. Got it? Now the time taken by the sound to reach from splash is this. Okay, so t2 will be equal to distance by velocity. So distance is how much? Distance is 300 meter, and the velocity of the sound, because sound will reach, so the velocity of the sound they have given as 340 meter per second. So when we will calculate this velocity of the sound as 340 meter per second, so we have got time t1 as well as t2. Now the total time time any person heard splash sound after throwing a stone is how much? T1 plus T2. So we have to put here T1 is equal to root 100 600 by 9.8 plus T2 is 300 by 340. So when we calculate this, so our answer we will get approximately 8.7 second. So the total time required this. So our required result for this question is T is equal to 8.7 second. So I hope you have understood this, right? Now let us do question number 14.3. In 14.3, a steel wire of a length is how much? Length is 12.0 meter. Okay. Of mass is given as 2.10 kg. Okay. What should the tension in the wire? What should tension in the wire so that the speed of the transverse wave, so V is of the wire is equal to speed of the sound in a dry air, that is equal to 343 meter per second. So we want tension. We know that the tension relation, the formula, famous formula for tension is equal to root V by mu. No, sorry, it is not a V by mu. Velocity, we know that the velocity of the wave is equal to root under tension by mu. Okay. So we will use this formula. So V square will be equal to tension by mu. So from here we can find tension is equal to V square by mu. Sorry, V square into mu. So V square into mu is mass by length. So we need to put here velocity is equal to 343 into 343 into mass is 2.10 kg divided by length is 12.0. So when we calculate this, so our answer for tension will be approximately equal to, it will come approximately 2058.57, but we need to find how many three significant figures. So we have to use three significant figure. So we can use here 2.06 into 10 to the power 4 Newton. So this is our required answer for this question. I hope you have understood this, right? Okay. Now let us go for a question number 14.4. So in 14.4, the question they are saying that use the formula and to explain why the speed of the sound in air is independent of the pressure, increase with the temperature, increase in the humidity. Now let us consider the formula for V is equal to root under gamma into pressure by density. Now if we increase pressure, So what will happen? Density will increase. You know that whenever you will compress the air, so density will increase in such a way that ratio of pressure by density will remain constant. Hence, velocity is independent of pressure. I hope you have understood this, right? Now this is part A. Now we will talk about part B. So let us go for part B. Part B is increase with the temperature. So whenever temperature will increase, so what will happen? Density will decrease at a constant pressure. So if density will increase, then V is inversely proportional to the density. So if density will decrease, so what will happen? Temperature will increase. Okay. So sorry, if density will increase, so what will happen? Velocity will increase. So hence we can say that velocity increases with increase in temperature. Okay, got it? Now let us do question number C. Increase with the humidity. Now as humidity will increase, so density will decrease. Density of the air will decrease. So when this will happen, so what will happen? Velocity is inversely proportional to density. So which result in velocity is directly proportional to the humidity. So if humidity increases, so velocity will increase. Okay. So this is the fact for the question number 4.5. Now we will do question number 14.6. The 14.6, a bat emits an ultrasonic sound of 1000 kilohertz. Okay. If the sound meets a water surface, so what will be the wavelength of the reflected sound and the transmitted sound? See, there is a bat, there is a bat, okay, and it releases a ultrasonic sound to the water surface, to the water surface. So this is a water surface, okay. So what will happen? Some part of this sound some part of this sound will get transmitted to the water surface, so it will go inside like this, like this, like this, and some part it will get transmitted back in this reflect back like this. Okay. Now they are asking, a wavelength for this, lambda for the case of a, wavelength for the reflected one, and b, they are asking wavelength for the transmitted wave. Okay. Now they have also given that the velocity of the sound in air, that is v in the air, is 340 meter per second, and velocity in the water they have given as 1486 meter per second. Now it is very simple question. We need to do like this. See, first of all, I will go for a question number A. We know that lambda is equal to what? Lambda is equal to velocity by frequency. Since frequency won't change, frequency that is given as 10,000 kHz, that is equal to 10 over 6 hertz, it will remain constant. It will remain constant. Okay. So if it will remain constant, so what we are going to get, see here, lambda. So lambda for this will be equal to lambda for the air will be equal to velocity of the air is 340 meter per second divided by frequency is 10 over 6 hertz. So when we will calculate this, so we will get as 3.4 into 10 to the power minus 4 meter. So this is the required result for option A or A. Okay. Now we will go for question number B. Okay. So in question number B, lambda, we want lambda in water. So lambda in water is equal to velocity in water divided by, see, this was velocity in air. So velocity of the water in frequency. So frequency will remain same. So velocity of the water. So let us find velocity of the water. They have given as 1486 divided by 10 to the power 6 hertz. So finally, we will get lambda in water, right? So let us erase it. Lambda in water. So lambda in water, we will get lambda in water as 1.4. If we will round up, so you will get 1.49 into 10 to the power 10 to the minus 3 meter. So this is our required result for this question. Okay. This is the required result for this question. I hope you have understood this, right? So there are two different type of lambda. We have to find reflected wave and transmitted wave. But one thing you should remember that the frequency will remain same. See, here it is mu frequency, here also new frequency, here also new frequency. So frequency will remain same everywhere. Okay. I hope you have understood this. Now let us go for a question number 14.7. Now 14.7, the question is, a hospital uses an ultrasonic scanner to locate a tumor in a tissue. What is the wavelength of the sound in the tissue in which the speed of the sound is 1.7 kilometer per second and operating frequency is 4.2 megahertz? So what they have given? They have given the speed of the sound as 1.7 kilometer per second. So this will be 1.7 into 10 to the power cube meter per second. Now they have also given frequency as 4.2 megahertz. So this can be written as 4.2 into 10 to the power 6 hertz. Okay. Now what is the wavelength of the sound? So wavelength means what? Wavelength is equal to velocity of the sound divided by frequency. So velocity of the sound is 1.7 into 10 to the power 3 divided by 4.2 into 10 to the power 6. So when we will do this, so we will get a result as 4.1 into 10 to the power minus 3 meter. This is the wavelength. So this is the required result for our question. Okay. So I hope you all have understood this question. Okay. Thank you for watching the video. I will come up with the next solution for in the next part of the video. Hope you will enjoy that. Thank you.